Okie dokie. So section 4.5, integration by substitution. So the idea here is to recognize the chain rule and to use a reasonably formal method to undo it if we can't undo it ourselves. So, if I had something like the function cosine of 2x, and I take its derivative with respect to x, that's going to be negative sine of 2x times 2. Or I could write it as minus 2 sine of 2x. And now, since I have it right here, if then somebody were to ask me, well, hey, what's the antiderivative of negative 2 sine of 2x dx? Well, I could just tell them, well, obviously that's cosine of 2x plus an arbitrary constant, because I have it right there. Now, though, could you do this if you hadn't seen that derivative right before it? And possibly, right? Because I could look at this and say, well, I see, this sine of 2x there, and there's a minus, and I know the antiderivative of minus sine x is cosine x, and so I could guess. I could guess something like, oh, I think the answer is not minus, but positive cosine of 2x. And then I could check it. And when I check it, I take the derivative cosine of 2x, 2x, with respect to x. And I would get my minus 2 sine of 2x. And everything would be great. And I go, oh, yeah, okay, that's what it is. Now, though, suppose it is this antiderivative, minus sine of 2x dx. Well, again, I'd probably guess the cosine of 2x. Now I'll have to add a plus c when I get done, but that's what I would guess. And I would check. And of course, when I do that and take that derivative, hopefully we're getting to know that derivative pretty darn well at this point. I should get minus 2 sine of 2x. And, well, that doesn't match. Okay, I have that extra 2 in there. Oh, but I could fix that then by just changing this problem to be 1/2 minus 2 sine of 2x dx. And then by my guess and check method, I already know that then, oh, okay, so the answer to my antiderivative inside of here is that cosine of 2x, but I now have that 1/2 out front, no big deal, just write the 1/2 and cosine of 2x plus c. And so, I can kind of guess and check things, but at some point, it gets hard to just guess and check, and for certain cases, definitely. I do a lot of guess and check because I've done a lot of derivatives over the years, and so I know my derivatives and thus my antiderivatives pretty well. But there are times when it just gets more complicated, so we'd like to have a little more formal and stable method to do this sort of thing. And so when you think about it, what we're trying to do is, if we recognize that we're taking we're finding the antiderivative of something like f of g of x, like that, and then times g prime of x dx. When we have something like that, I recognize that the answer to this should be uppercase f of g of x plus an arbitrary constant. Now, I have to tell you what this uppercase f is, so where f prime of x, uppercase f prime of x, is equal to little f of x. And so that's the kind of thing we did with our guess and check, was we noticed that, oh yeah, you know, we're trying to undo this chain rule here. And this would be the way that the chain rule would work, is that if I wanted to take the derivative of this function here, uppercase f of g of x, right, the answer to that, the derivative of f of g, lowercase g of x with respect to x by the chain rule, is that f prime of g of x and then g prime of x. And so the antiderivative of this is just our uppercase f of g of x. And so that is, you know, what we're trying to get at. And the way we do it, the reason it's called substitution, is that we use differentials. And so if I have this antiderivative of f of g of x, and you know, I could find that g prime of x dx if that was there, what I can do is I can make the substitution that if I let u equal g of x, then du, okay, this is our differential idea, by definition is g prime of x dx. And so I can substitute those pieces in, and you see that makes this a simple, depending on what f is, but a simple antiderivative, right? It's just that function, and hopefully I know its antiderivative, and I could find that. And so suppose its antiderivative is uppercase f of u plus a constant. Okay, so we have f prime of u equals little f of u. Again, that's not a standard notation, so we need to let people know. But then this is uppercase f of g of x plus c. And so that is the substitution technique. So if I'm just given something like, I would like the antiderivative of, say, 2x times the square root of x squared plus 1 dx. I look at this, and typically I see a multiplication, and I think, okay, is that multiplication, does it look like it's due to the chain rule? And you see, I see that x squared plus 1 inside the square root function. And I think, well, what's its derivative? It's 2x. And so, yeah, I think this probably came from a chain rule. And so I'm going to let u equal that inside part, x squared plus 1. And then the differential is that derivative, so 2x dx. So du is 2x dx. And there I have 2x dx. And so I can do a substitution and write this as the square root of u du. And I can do that antiderivative. That's u to the 1/2, so that will be u to the 3/2 divided by 3/2 plus a constant. And so this is equal to 2/3 u to the 3/2 plus my arbitrary constant. But now substituting back for the u, I have 2/3 x squared plus 1 plus my arbitrary constant c. So that's the idea. And I think probably the best thing to do is just, look through some examples from look through, do some exercises from the exercise section and kind of see how those go. So that's what we'll do.